Hello everyone, in this video I'm going to discuss the function and graph. A function of h is defined by the situation given. Find the function of f if the f rho h which is equal to 1 over x plus theta 4. So kindly determine the domain and also the range for the f. So what we have to do now is to find the function of f. So f rho h which is equal to 1 over x plus theta 4. So in here we have the situation given. So f bracket with the hx. So my suggestion will be let the hx which is 3x minus 1. So express x as a subject. So x will be equals to y plus theta 1 over the 3. Kindly substitute the situation. We have fy which is equals to 1 over. So we have y plus theta 1 over the 3 plus theta 4. Kindly equate the denominator. So we have y plus theta 1 plus with the 12 over the 3. So fy which is equals to 3 over, we have y plus theta 13. So that is the fy, or we can say the fx which is equals to 3 over x plus theta 13. So from here, the domain would be negative infinity until negative 13 union negative 13 until infinity. Next, what we have to do is to find the range. Before we find the range, let us focus on the inverse for the f. So f inverse of x. Let's say we have y which is equals to fx. F inverse of the y which is equals to x. So in here we have y which is equals to 3 over x plus theta 13. So we have x which is equals to 3 over the y minus the 13. So f inverse of the x which is equals to 3 over the x minus the 13. The domain for the f inverse which is equals to negative infinity until the 0. Union start from 0 until the infinity. So actually this is the range for the f. So where we have negative infinity until 0, union 0 until infinity. So we already find the f including the domain and range and also the f inverse. Now is to sketch the graph for the f and f inverse on the same axis. So given the situation, we have fx which is 3 over x plus theta 13, and we have the f inverse of x where we have 3 over the x minus the 13. So let's focus on the fx. So here we have y which is equals to 3 over x plus theta 13. So the domain for the f would be negative infinity until negative 13 union negative 13 until infinity. So here we have the asymptote which is x is equals to negative of 13. That is the first one. The second one, we have the x-intercept when y is equal to 0. So the value of x does not exist. Next, find the y-intercept when x is equal to 0. So the value of y will be 3 over 13. Next, continue. Number 3, focus on the direction. If we refer to the x where we have the positive, so the graph will be something like this. So let's begin. Focus on the, so in here we have number 1 which is negative 13. So let's say we have 2, 4, 6, 8, 10, 12 and 14. So let's say here we have the negative 13. So x which is negative 13. So the graph will be something like this. Then continue. We have the graph where we have 0, 3 over 13. So let's say here we have 0, 3 over the 13. Next is to find the situation where we have to flip the graph based on y which is equals to x. So here we have y which is equals to x. So the graph will be, if the situation we have x which is equals to negative 13 and also the asymptote y which is equals to 0. So if we flip the situation, it will become x is equals to 0 for the y equals to 0. Another one, y which is equals to negative 13. So let's say the situation is over here. So y, which is equals to negative 13. Then the point, we have 0, 3 over 13. So now we have the situation over here, where we have 3 over 13, and then we have the situation 0. So the graph will be something like this. Then another part, the graph will be something like this. So that is the graph of f inverse of x. So here we have the graph fx. So do remember to label the xy axis, y is equals to x, and also the intersection point, and also the asymptote.
Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.